Let's dive into a revolution that's happening right now, kind of quietly, on factory floors all over the world. You know that same AI that powers chatbots? Well, it's now giving industrial robots a brain. And trust me, it's changing absolutely everything about how we work with machines.
Okay, just think about this for a second. What if you didn't have to be a super skilled engineer writing lines and lines of complicated code just to program a robot? What if you could just talk to it? I mean, imagine walking up to a machine and just saying that. A few years ago, that was pure science fiction, right? But today, a robot can actually understand that command, break it down into all the necessary steps, and then just do it flawlessly. So what's the magic here? Well, it's the technology behind stuff like GPT-4, large language models, or LLMs. And it turns out they're not just for writing emails anymore. They are literally giving industrial robots the power to understand us, to reason, and to communicate back. So let's break down this first massive change. We are fundamentally shifting away from writing complex code and moving into something way more natural, simple conversation. The first huge shift is all about how we give robots their marching orders. We're moving away from the rigid, unforgiving grammar of code, the syntax, and into semantics, which is just all about understanding the actual meaning and, the intent behind our words. And, just look at the difference here. It's night and day. Before, you needed specialists writing this super rigid code for every single tiny movement. Now, pretty much any worker on the factory floor can just give a high-level command in their own language. This whole idea has a name. Experts are calling it the democratization of robotics. It radically cuts down what's called the time to task. Basically, a robot can learn a brand new job in just minutes instead of weeks. And this frees up the engineers to focus on the big picture, on optimizing the whole system, instead of getting bogged down with just one machine. But this is where it gets even more interesting. This whole new way of communicating, it's not just a one-way street anymore. It's actually becoming a real partnership. In the past, if a robot stopped, you'd get some cryptic error code flashing on a screen, like error 507, and you'd have to go hunt down a giant manual to figure out what that even means. Now, you can just ask, hey, why'd you stop? And the robot can answer you, turning this whole thing into a real dialogue. That builds trust and makes fixing problems incredibly fast. Think about this for a second. Instead of just failing and stopping, the robot can recognize it's uncertain about something, pause the operation, and ask its human teammate for help. This is an absolute game changer for handling all the little ambiguities that happen in the real world on an assembly line. Okay, so robots can understand us now. That's huge. But the next phase of this whole revolution is even more profound. It's about moving beyond just blindly following instructions to actually thinking, adapting, and solving problems on the fly. Because LLMs are trained on these insane amounts of human knowledge from the internet, they give robots this layer of common sense reasoning. This lets them figure out solutions to problems they've literally never encountered before. And this is such a critical shift. A traditional robot is, it's brittle. If a part is just a tiny bit out of place, the whole system can just break down. But an LLM-powered robot, it's flexible. It can understand the context of the situation and figure out a new way to get the job done. So let's paint a picture. Imagine a robot's job is to unload a pallet, but one of the boxes is torn wide open. An old robot would just freeze up, fail. But the new LLM robot, it actually reasons through the problem. It sees the box is damaged, it understands that the small parts inside need to be collected carefully, and it comes up with a whole new plan to handle the situation safely. It's amazing. So how are these robots getting so smart? Well, how they learn is a fundamental change from anything we've done before. So, the old way of teaching a robot was a total grind. You had to feed it thousands and thousands of perfectly labeled images in these huge structured data sets. It was slow, it was expensive. Now, an LLM can just ingest all of a company's existing knowledge. We're talking PDF manuals, internal wikis, even old maintenance reports, and learn directly from it all. Let that just sink in for a second. You can give a robot the instruction manual for a brand new piece of equipment it has never seen before, and it can generate the assembly plan all by itself. It's like having an assistant that has read every single document your company has ever produced. Okay, the final piece of this incredible puzzle is putting it all together. The LLM doesn't just control one robot. It can actually act as the high-level brain or, the conductor for an entire workflow that involves multiple robots and humans. So you give the LLM a big top-level goal, like complete this order. It then takes that goal and breaks it down into all the smaller tasks. Then it assigns those tasks to the best resource for the job, whether that's a robot or a person, and it monitors everything, adjusting the plan in real time as needed. It basically becomes the workshop manager. All right, so this all sounds great in theory, right? But this isn't just theory. Let's take a quick look at where these revolutionary capabilities are already being put to work in the real world right now. We're seeing it in flexible assembly lines that can switch what product they're making on the fly, in giant warehouses where robots can find replacements for stuff that's out of stock, in quality control where a robot can actually describe a defect in plain English, and especially in cobots that are becoming true partners, even anticipating what their human colleagues are going to need next. Now, as exciting as all of this is, let's be realistic. The road to the fully automated smart factory isn't completely smooth. It's really important to have a balanced view and look at the challenges we still need to solve. First up is safety. This is a big one. LLMs can sometimes hallucinate or just make stuff up, which is obviously a no-go in an industrial setting. There's also the challenge of grounding, which is about reliably translating abstract words like pick up the gear into super precise physical movements. And finally, just getting all this advanced software to play nicely with complex hardware in real time is a massive engineering hurdle. But as we solve these challenges, and we will, we're marching toward a future where our robots are being transformed from simple tools into intelligent, communicative collaborators. And that leaves us with a really fascinating question to chew on. When our tools really do become our teammates, what will our job be?